Well, this is a recap video about the variable in Java. And in Java, there are two types of variable. The first is parameter type, and the second is reference type. And the difference between the parameter type and reference type is that for the parameter type, this is the variable belong to the system, right? This is the first one. And from the parameter type, we can define all reference type like the class, interface, and other things. As we also really notice that there is string, the string in the reference type, and what is belong to the reference type is that at the first it's like the chart, which we create the array of the chart, so that this becomes a string literal, so it's the reference type. And the difference between the parameter type and reference type is that, like, for parameter type, it's stored in the stack. It's stored in the stack, and for the reference type, it's stored into the heap. And for the string inside the heap, we have the string pool. So this is where the string is stored inside the heap. And there is the size of parameter type and the byte source in range, and each of them have its range. For example, for the byte, we have the range from negative 128 to 127. So if we this is something we have to consider, because for example, if we need something too small but we choose the integer, right, it's going to be redundant. For example, like for we want to denote the index for the student in the class, and the student range from 1 to 14, it's going to be redundant if we mark it as the int, because you can see it ranges from 2 million. Means why we need to do something represent from 0 to 14, so it's going to be more memory effectively if we choose byte. And what is mean of the bit, the size of the each parameter type is that, as you see here, because we the human, so we can understand this representation, the integer, right? This is more intuitive for human, but for the computer, the only thing is understand here 1 and 0. So we need to do something that converts this into the 1 and 0. So in the Java, there are GVK gonna do something like that. It's gonna transform the integer into the bytecode in the compilation period. So first, I'm gonna take a sample of byte. For example, I want to display the byte, and then I name it a number of student. It's equal 42, right? What it really happened is that in the compile time, the computer generates it into the bytecode like this way. You see here is the bytecode of 42, and how it can do, right? There is, as you hear, it's present into the A port, and one port represents for one bit. And for first part, from it's going to represent the size of this one. As you see here, it's from negative to positive. And how computer know it's negative or positive? It's from the first part right here in the left, it's going to represent 0. It means the positive, as you see here, and 1 it means this one is negative. And it transform 42 from the right to left. So first it's going to see, it's going to take 42 divided by 2, and it's equal 21, and the remainder is 0, right? So the first the remainder is this here, it represents 0 right here, and then I'm gonna take the remainder like the 21, and it's gonna divide it by 2, and it's equal 10, and the remainder is E1. So it's going to take the place right here, as you see, 0 and 1, and then I take 10 divided by 2, and it's equal 5. right? And the remainder is 0. And this process gonna continue, right? 5 divided by 2 is equal 2, and the remainder is 1. And then I test remainder 1 divided by 2 is equal 0. This is my back, right? The remainder is 2, so 2 divided by 2 is equal 1. And the remainder is so it's equal 0, and then I test 1 divided by 2, and it's equal 0, and it's 1. So this is the representation of 42. And the first one is, you see here, there are still place for itself. For example, I still divide this, right? Divide this by 2, it's still 0. And the first one is designated the size of this number is the 0, right? It's still 0. So this is the byte code of 42. Then another concept is the conversion, like when for this type, when I want to transform the char to the byte or the source into the int kind of thing, right? Sorry, from a byte to short and int to long, not from char to byte, I'm sorry. And there are two types of conversion. The first is implicit type conversion. Other word is the wider. Is when we transform a smaller data type into the larger data types. For example, we transform from a byte to short, right? It's the size of the byte is 8 bit, and the size of short is 16 bits. So it's easy for us to transform from a byte to short, right? Because, for example, we still have a room for example, like 42, the range is 42, and we want to transform to short. It still have the room for itself to represent, right? You see here, it can transform 2,000 above to this one. So it's easy for us to transform from byte to short. So the system gonna automatically do it for us. For example, you see the example, like when we display the integer number and then we insert it into the double D, it automatically do for us. For example, it's gonna represent as the double right here, 10.0, and this is the guidance conversion order from a byte to short to int to long, and long to float, and float to double, right? From the smaller to the bigger one. But what happens if I want to transform the double to float? Right, this is the narrow type casting. For example, you see here, this is narrow type casting. It transforms from the larger to smaller type, and the system requires us to explicitly tell the system what is going to cast to. For example, I include the int inside the bracket, and then I put the D before I insert it into the integer, so the system knows that I want to transform the double into the int, right? And during the conversion, it may be reduced. We may lose some data, because for this we display the double 10.99, right? But the integer cannot represent like a double, so it's only represent the integer, so that it needs to cast down this number. So you see here, when the print output, it's going to play a 10 only. It's going to be represent down rather than it's increment up. and this is the order of narrowness conversion. And when, for example, like what happens when we casting, for example, like I declare the short, like it's for when I narrowing down, I casting from the number to the lower number one, and this is our range of the lower. What happened is that, like for example, I declare the short of 1, 2, 9, right? And for 9, it is out of the range. So what happened if I like this? I name it as B, right? By equal A equal B. What happens if I insert that? Right now, it's when we print out, it's going to present like negative 1. It's going to go back. It's going to go back to the negative 1. So when we put something out of the range, it's going to rather represent 189. It's going to go back and then go back. This is all because I remember. And the third concept is type of motion in expression, like when we perform the operation, like the mathematical, arithmetic, semantic, like when we add them together, or this experiment or kind of thing. For example, when we add 2 pi together, right? It's gonna result. It's going to promote 2 inches before the operation. For example, right, the range of pi is 100 up to 127, but right now it's as 10 and 20. But when I add them, it's going to be appear an error if I not custom or promote them to integer. Right, I have to promote some to integer before I perform the operations. Right, when it's added to 20, you see 20 is still a range of the byte, but we have to convert it into the int first. When it's declare promote it into the integer. Right, and the second image data type to larger type. Alright, for example, both of 2 prime is byte, but there in the second it's the first prime is integer and the second is float. What system gonna choose, right? It's gonna choose the larger one, the larger type, right? And you see here the largest type in the expression. First, like when I ask the integer into the float, the integer first promoted to the float, and then the double, and for the float it's gonna promote it to the double, and then them add together, and the result must be the double. Right. It's still the same story for the double type, but the decimal type, right? Long float or double, it still converts to the larger one, the largest one, right? This is the largest one, is double. It's the 4. Oh, all of them is 42 bits. Oh, it's just the difference between the representation. Anyway, it's gonna represent into the double instead of long. I may miss something. I might know something right here. Okay. And the fourth concept is type conversions. There are three main type conversion: the local variable, instant variable, and the static variable. As for the local variable, you see here for the definition, it's declared inside the methods constructor or block. Scope with this block, but it is clear, right? For example, for the class, and inside class we declare the variable, and this variable belong to this method. So that, for example, in the main we call this class and we call this method, and this variable only belong to this objects, and we cannot access it from outside, right? So that's when we the scope of this is limited to the function itself, the method itself. And the second is instant variable. For example, for the class we display two fields, string name and age. Not displayed inside the class, not outside the method, but outside the methods, right? This is the difference between the instant variable and the local variable. For the local variable, it is declared inside the method, but for the instant variable, it is declared outside the method. And this is the view of the class, right? When we create initialize the objects of this class in the main, every object gonna contain this field. Each one gonna contain this field, right? The string and the int, for example, the person right here. You see, in the main, I display the person. I allocate into the heap, and then I assert the name for John and age. Right now, I can still access it because maybe I display a public, so that by default the class display at the public, so that I can access it outside. As you see here, maybe I set it in the main. And static variable, or other word is a class variable. Display inside a class using a static keyword and says more or object of the class. Stored in the methods area, not in the heap memory. And what it really means is that, for example, in the class we display the field, and then we include the keyword static, as you see here, right? This is the only difference with the instant variable, that we put the static keyword, and static keyword is going to make this variable belong to the class itself, right? It means that every object created from the class going to share the same variable, right? For example, for this one, when I create the person one, I call the constructor, and it's gonna have its own name and age, right? If I call a person 2, and I can assert another name and age, and this name and this age gonna belong to this B2 only, right? This name and age belong to P1 only, right? But for the static variable, when I declare the person employee, you see here, it can say all to all class, like the employee E1, employee 2, right? It can share the same variable, and this not stored into the heap but in the methods area. Okay, it's done. I think it's done. There are some concepts that I still forgot, like converting.